Okay, let's take a look at simplifying rational expressions. So we're at page 371 in your workbook. If we just take a look at the first little bit, all it's going into is the fact of what a definition of a rational expression is. So rational expression essentially is a fraction. However, rather than just numbers, we're dealing with polynomials in the numerator and the denominator. Remembering that a number on its own, a constant, can also be called a polynomial. So what we're looking at this unit then is how to operate with rational expressions, so add, subtract, multiply, and divide, as well as solving problems when we get into solving rational equations. So, as I've mentioned many times before, big thing is our ability to factor, and factor. So in terms of factoring, we know that we can look for common factors, difference of squares, if there's two terms, and if there's three terms, factoring trinomials by inspection, so that's kind of doing your variety of different kind of guess and check methods. And then if there's four or more terms, then factor by grouping is what we'll look at. So take a look at page 372, and so this is saying, and then quick investigation on equivalent forms. So if you think about equivalent fractions, this is essentially the same thing. So what we're looking at are two different rational expressions, 2x plus 2 over x squared plus 3x plus 2, and 2 over x plus 2. So they're just asking you here to substitute 0 in for x in both of them, and for substituting in 1 and 2. So let's just look at a couple. We don't need to do all of them. Let's look at 0, 2, and 4, substituting those ones in. So I'll hit pause, and you should hit pause too and complete those spaces in that table. So what we should notice then is when we substitute in the same value into both rational expressions, the values end up being equal. So the value of those expressions are equal. And so what can we say is, well, they're the same, and therefore they are equivalent forms. So exactly the same as how we would talk about equivalent fractions. So how do we show that they're equivalent is if we factor them. So taking a look here, we want to cancel factors and not terms. So if we take 2x plus 2, we know that there's a common factor of 2 here, and so factor that out. So it's 2 times x plus 1. Factoring x squared plus 3x plus 2 is x plus 2 and x plus 1. And what do we know is that x plus 1 times x plus 1 is, x plus 1 over x plus 1 is 1 over 1. And therefore we have 2 times 1 over x plus 2 times 1, or 2 over x plus 2. Okay, so you cannot cancel until they are factors. And so if you see here, it says to reduce fractions, we cancel factors, not terms. Okay, so bringing it back to numbers as a bit of a reminder. For example, if you have something like 4, 6, we can say, why do we reduce it to 2/3? Is because we know that 4 is 2 times 2, and 6 is 2 times 3, and so 2 over 2 is the same as 1 over 1. So that's why 4, 6 is the same as 2/3. What can we not do? I cannot take 4, 6 and say, well, that's 2 plus 2, and 6 is 2 plus 4. I cannot cancel the 2's here and say that 4, 6 is the same as 2/4. This is definitely a no. So we won't be doing that. So that's why we're saying we're canceling factors. It has to be all multiplication, cannot be addition or subtraction. So let's take a look then at the next key piece here, which is investigating non-permissible values. So when x is 0, well, so why don't you take a moment and work through that table, and we'll come back in a moment. So just hit pause. So what we want you to notice from this table is that when we substitute in -1 and -2, the value of both expressions are undefined. And why are they undefined is because your denominator ends up being 0. So we can say for each value or values, -1 as well as -2. For the second expression, it's only -2. So why is it that they're not defined? Of course, we can't divide by 0. Okay. And so the key thing to notice here is that if we only use the factored form, meaning the 2 over x plus 2, we don't get a chance to see that -1 is going to result in it being undefined. And so what we need to look at is the original, which is the x squared plus 3x plus 2 as the denominator. So scrolling down, we call these the values of x are non-permissible values. We also call them our restrictions too, so non-permissible values or the restrictions, and they are the values of the variable which make the denominator equal to 0. So they have different restrictions, so we need to make sure the restrictions are determined before, key word being before, dividing out any common factors. Okay, so any non-permissible values, anytime there will be non-permissible values, anytime there's a variable in the denominator. Okay. So rational expression is in simplest form if its numerator and denominator have no common factor other than 1. And that, of course, is true if we're talking about just rational numbers, so just fractions with numbers. So express in simplest form, stating non-permissible values of the variable plus example number 1. So we'll take a look at the first one. We know that we can take out a factor of x, so this one reduces with this one, and then 12 over 2 is 6 over 1. So we're looking at just simply 6x, and non-permissible values. I want to look at this before I crossed anything out. So the answer is 6x, but only when x is not equal to 0. When we look at the second one, well, we know that we can cancel out a plus 1 and a plus 1, that's 1 over 1. So simplest form is a minus 6 over a plus 7, but that is only true when a is not equal to -1. Because we're looking at when is that factor equal to 0. So a plus 1, if you need to, then you write down, well, a plus 1, when is a plus 1 not equal to 0? Well, when a is not equal to -1. So that's, if you need to write that middle step, that's totally fine. Okay, if we take a look at C, so for C we've got y plus 4. We don't know if this denominator has any common factors with y plus 4 until we actually factor it. So we've got y minus 5 and y plus 4, and I would strongly recommend, if you start running into issues where you might get tempted to cross out x squareds or something, put the whole numerator in brackets, the whole denominator in brackets, because it's an all or nothing deal. So same thing with this one then. We can see that y plus 4 over y plus 4 is 1 over 1. So then simplest form is 1 over y minus 5. Our restrictions are y cannot equal -4 or 5. Okay, when you have multiple restrictions, ideally it's kind of nice, because you can imagine we're going to get to some situations where we will have quite a few restrictions. If you put them into numerical order, that would be greatly appreciated. It's easier to keep track of that way, kind of scanning through, making sure that we've got all of them. Okay, so if we take a look at D, then we need to factor this first. So it's possible that both the numerator and the denominator need to be factored. So in the numerator, we've got x plus 4 times x plus 7. In the denominator, this is a difference of squares, so it's x plus 7 and x minus 7, and x plus 7 over x plus 7. Make that 1 over 1, so that means I'm left with x plus 4 over x minus 7, and that is only true if x is not equal to negative 7 or positive 7. Okay. So for those of you who like to put a square or a box around your answers, that is your full answer. It's not just the simplified form, because that simplified form is only true when the restrictions are in place. Okay, so part B is up. There's a number of questions that have been assigned that you can refer to your unit plan for.